So in this case, a car is at rest at a traffic light. When the light turns green, the car takes off, accelerating uniformly for 30 seconds to a velocity of 15 meters per second. At the same time that the car takes off, a truck passes it, traveling at a constant velocity of 10 meters per second. The following graphs represent the motion of both vehicles. So we can see it's a very nice graph. Now, if you look at the questions, there's a special instruction there. They say use only the graph, not equations of motion, to answer the following questions. So this means if you use the equations of motion, they are not going to entertain your answers. Right. Now, the first question actually says, after how long will the car and the truck have the same velocity? So in order to answer this one, we have to look at where both of these graphs intersect. And this is at this point. So this means after 20 seconds, we can see that the velocity of the truck will be 10. The same applies to the velocity of the car. Awesome. And then the next question says, describe the motion of the car after 30 seconds, meaning in this region. So here you'll tell them, well, the car is moving at a constant velocity in the original direction. Either you say in the original direction or in the direction of motion, because you can see that the velocity is not changing after 30 seconds. Fine stuff. Then the next question says, calculate the acceleration of the car after 30 seconds for 3 marks. So here you have to know that the gradient of a velocity time graph will actually give you the acceleration. So you could have decided to say gradient equals change in y over change in x, but your change in y will be change in v, and then your change in x will be change in t. Then calculate the value of the gradient and then conclude, say, therefore the acceleration is this much. But alternatively, you could have went straight to the definition of acceleration and say acceleration is the rate of change in velocity. So both of these are equally correct. So you say the final velocity will be 15, initial velocity is 0, the final time is 30 seconds, the initial time is 0. Now, if you press your calculator, you realize that the acceleration is 0.5 meters per second squared. But if you look at the question thoroughly, they didn't say calculate the magnitude of acceleration. No, they said calculate the acceleration. So if they say this, you have to give the direction as well. So you'll tell them it's in the direction of motion or in the original direction. It's up to you. Fine stuff. And then the next question says, how far ahead of the car is the truck after 30 seconds? So in other words, what is the distance between the two vehicles if the truck is ahead? Do you see that? So the first thing we must do here is to calculate the distance, which is the displacement because it's motion in one dimension. We find the distance of the car after 30 seconds. We also find the distance of the truck after 30 seconds. And then the difference between the two distances will be how far the truck is ahead of the car. Do you see that? Right. But remember, they said don't use equations of motion. So for this one, you have to know that the area under the graph of a velocity time graph will actually give you the displacement. That's what you had to know. So let's go ahead and find the area under the graph of a car. So remember, we are interested in the first 30 seconds. So if we look at the car, we can see that the area under this graph, it's going to be a right-angled triangle. Do you see that? And in order for you to find the area of a right-angled triangle, you just say it's half base times the height. So what is your base? Your base will be 30 seconds. And then your height will just be 15 meters per second. So let's see how much you get when you press this into your calculator. So you find that the area under the graph will be 225 meters. Then you can conclude and say, therefore, the displacement of the car will just be 225 meters. Then we come back and look at the truck. So similarly, we want to find the area under the curve of the truck. But if you look at this one, in the 30 seconds interval, you can see that for the truck, you actually have a rectangle. Do you see that? Now the question is, how do you find the area of a rectangle? You say length multiplied by the breadth. And then you'll say the length of this will be 30 seconds. The breadth will be 10 meters per second. So if you say 30 times 10, you get 300 meters. Then you can conclude and say the displacement of the truck after 30 seconds will just be 300 meters. Then you tell them that the truck will be ahead of the car by how much? By 300 meters minus 225 meters, which when you press into your calculator, you get 75 meters. So this is the distance between the two vehicles. Fine stuff. So what does the last question say for 7 marks? This one was 6 marks. So it says, calculate the time taken for the car to catch up with the truck. So they tell you that that time will be TX seconds. So what is the meaning of the car catches up with the truck? This means the final positions must be the same. So the final position of the car must be the same as the final position of the truck. That's the condition for the vehicles to catch up. But if you look at these ones, like this situation, the initial positions of both the car and the truck, it's going to be 0. Why is it 0? So for the car, it was at rest, right? So the initial position is 0. It makes sense. But the truck was already moving, right? So it has to have a certain position, right? And in the actual fact, it does have an initial position. But remember, we are not interested in what happened to the truck before it passed the car. No, we are actually interested in the moment it passes the car up until. So we can safely say the initial position of the truck will be 0. I'm sorry for the long explanation, but what I'm trying to say is, since the initial positions of both of them are 0, in this case, we can safely say for the car to catch up with the truck, the displacement of the car must be equal to the displacement of the truck. Are you fine? Awesome. Now, once again, we have to find the displacement of the car. But now, for what part? From t equals 0 to t equals x. Do you see that? So meaning we have to find the area under the curve for the entire motion. Do you see that? Now, one thing you realize is that this entire motion we are referring to consists of 2 figures. We have a right angle triangle, and then we have a rectangle. Do you see that? Awesome. And this is what I want you to see. So already we know that the area under the curve for the first 30 seconds is 225 meters. Now we have to find the area for this region from 30 seconds to t seconds, or x seconds if you like. Now here we see it's a rectangle, so the area here will be given by length times the breadth, right? Now the question is, what is the length of this rectangle? Well, the length of this rectangle will just be t minus 30 seconds. Where does it come from? It's because we want to know this portion. So in order for us to know that portion, we must find the difference between the 2 times. The same applies if we want to find this time interval. We say 30 seconds minus 0, then we get 30. Do you see that? So your length will be t minus 30, and then your breadth will be 15 meters per second. Now, simplifying this, we get 225 plus 15t, and then you say minus 450. Am I right? Let's check. Yes. Now, if you say 225 minus 450, you get negative 225. So this is the area under the curve for the car. But the area under the curve is actually the displacement, right? Fine stuff. Then we come back and find the area under the curve for the truck now. Now, if you look at the truck from t equals 0 to t equals x, this is the part I'm referring to. So here you don't need to say, break this one into 2 parts so that you can have this one added to this one. There is no need for you to do that. So here you can say the entire rectangle because it's just one figure. So because it's just one figure, you say its length multiplied by the breadth. So the length of this rectangle will be t seconds. Because it starts at 0, it ends at x, or rather at t. So the total time there, it's t seconds. Then you multiply this by the breadth, which is just 10 meters per second. So this means the displacement of the truck will just be 10t meters. But we said in order for the car to catch up with the truck, the 2 displacements must be equal. So then we equate them. So you say 15t minus 225 equals 10t. Then you take 10t to the left, it becomes negative. You take 225 to the right, it becomes positive. So 15 minus 10 is 5. And then here you get 225. Dividing both sides by 5, you get 45 seconds. So your t will be 45 seconds. Or if you like, you can say tx is just 45 seconds. So this should be it for this video. Thank you so much for watching. I really hope it helps a lot. And please don't forget to subscribe to my YouTube channel. Let's see you in the next one.